Hello my dear students, today we are going to discuss about activation energy. If you take a chemical reaction, in the chemical reaction, reactants are converting into products. If reactants want to convert into product, we need to supply certain amount of excess energy to the reactants in a chemical reaction to convert into products. That excess of energy which we are supplying to the reactants in a chemical reaction is called as activation energy. So I will explain this activation energy with the help of graph. You will get more clarity about it. So here I am taking one reaction, R gives P. Have you got it? R gives P. You see this. Okay. So R reactants are converting into products. Here focus on one important point. Generally reactant molecules contain certain amount. That energy we call it as like a ER. You see this. ER means what? Amount of energy present in the reacting molecule. But how much it wants to convert into products, that amount of energy we call it as like a ET, threshold energy. If reacting molecule contains threshold energy, then only they convert into products. Have you got it or not? But actually, how much energy they contain? ER. But how much they want to change into product? ET, threshold energy. So now here you see this gap. This is called as, here you see this. This is called as what? We need to supply this excess energy to convert into products. That is activation energy. Have you got it? This is called as activation energy. EAF. Why are you writing F, sir? F means activation energy for forward reaction. Forward means reactants convert into products. Have you got it or not? So total amount of energy required to convert into products is called as ET. Okay. How much amount we need to supply to the reacting molecules? EAF. Okay. How much amount already present in the reactants? ER. Have you got it? So here you see this next step. ET is equal to EAF plus ER. You see this total. This total ET is equal to EAF plus ER we have taken. So now if you want activation energy for the forward reaction or simply activation energy for the R gives P, okay, EAF is equal to threshold energy minus energy of reactants. ET means threshold energy. That means if reactants want to convert into product, they should possess threshold energy. How much energy reactants are containing already? ER. That means energy of reactants. If you subtract ET minus ER, you will get activation energy. Have you got it or not? Right. So now we discuss some more important points which are useful for our objective examination to solve questions like IIT JEE and NEET questions. You see this. Generally, heat of the reaction, that means enthalpy of the reaction, we can calculate. Delta H is equal to EP minus ER. Okay. So now you see this EP minus ER. Delta H is equal to, with the help of activation energy also we can calculate. How, sir? Activation energy of forward reaction minus activation energy of backward reaction. Okay. So if you subtract these two, you will get delta H value, enthalpy of the reaction. Is it clear? Now go to the very important point. Here see, if activation energy is low, okay, if you give small amount of energy to the reactants, what will happen? That reaction takes place fastly. Because activation energy is low, reaction is faster. Next, activation energy is high, reaction is slower. Keep it in your mind. Next one, if activation energy is zero, already molecules are having needed energy, then what is that reaction? That is called instantaneous reaction. Have you got it? Simply you can relate EA value with K, rate constant. K is inversely proportional to EA value. Have you got it? So K means rate constant or specific rate constant. Have you got it? Next, important point here, next one is EA depends on what, sir? Generally, EA depends on nature of reactants. We can also say catalyst. Have you got it? If you use catalyst, changes the path of reaction where the activation energy is lower. Okay, so catalyst, EA value depends upon the catalyst and nature of the reactants also. Have you got it, these points? Now, so I'm taking one more graph. I want to tell you which type of reaction the given one. So I have taken this graph. You see this graph. In this graph, what we are going to do is, see, they gave this graph. So what is this? Is it exothermic or endothermic? How can we calculate? Very simple. You see this EAF is given and EAB is given. EAF, EAB. Both. EA value smaller, EAB smaller, EAF. EAF minus EAB. If you do, here negative value you will get. You see this, negative value. So therefore, here if the delta H is negative, the given what? Reaction is a exothermic reaction. Have you got it what I am talking? Like this, you can calculate with the help of graph the given reaction is exothermic or endothermic. It is exothermic. Now you go for this dear. So and tell me, is it exothermic or endothermic? It is a endothermic. Have you got it? How can I say it is endothermic? See this. EAF is bigger. Bigger minus EAB. EAB is small. Bigger minus smaller. Resultant is positive. That's why this graph is belongs to endothermic and the last graph is belongs to exothermic. Have you got it? Thanks for watching. Bye bye.